Okay, so today our topic of discussion will be acid and bases. Okay, first of all, let's discuss about acids. Okay, so definition of acid is quite important. An acid is a substance, that release hydrogen ion when dissolved in water. When dissolved in water. Okay, so acid हमारे पास कोई भी ऐसा substance है that when it is dissolved in water, then it is going to release hydrogen ion. Like for example, HCl. If we are going to put in water, then what happen that HCl would be split up into H positive ion and chloride negative ions. Okay, so this is HCl. This is hydrochloric acid. Okay, you have to memorize their formula as well. Hydrochloric acid, okay. And then we have sulfuric acid, which is H2SO4. And when it is dissolved in water, then it is going to release, or you can see like there are two hydrogen ions, so they would be releasing two hydrogen ions. Along with it, it would be releasing sulfate ion, okay. So this is sulfuric acid. You have to remember their formula as well. Sulfuric acid. And then moving further, there is nitric acid, which is also important. Okay. Nitric acid. So when it is dissolved in water, then again it is going to split up into H positive ion. Along with it, there is nitrate ion. Okay. So this is a concept that is related to acids. Remember that this definition is very important in your CI's exam. Okay. Moving further, let's discuss about that there are basically two types of acids. The types of acids. One type of acids are basically mineral acids. Okay. So mineral acids are those acids which are man-made. Like for example, HCl, which is hydrochloric acid, then is H2SO4, which is sulfuric acid, then is nitric acid. Okay. Then we have phosphoric acid, that is H3PO4. Okay. So this is phosphoric acid. The other type of acids are basically organic acids. Organic acids are those acids which occur naturally, okay? Which occur naturally, like the one we have, for example, is malic acid, which is present in apple. Malic acid present in apple, okay? Then we have the other is citric acid, okay? Citric acid that is present in citrus fruits, okay. This is present in citrus fruits, okay. So these are basically, the common types of organic acid, okay. Let's move towards the next part. So let's discuss about the properties of acids. Properties of acids. First of all, acids, there are some physical properties. So let's discuss some of the physical properties of acids. The one is they have sour taste. Okay. Then we have they turn blue litmus red. They turn blue litmus into red color. Okay. Then we have what they do. Acids dissolve in water. Acids dissolve in water. Okay. And dissolves in water, and then they conduct electricity. And then they conduct electricity. Okay. Why they conduct electricity? Because in that condition, they would be split up into ions. Like for example, we know about acids like it's HCl. When they are dissolved in water, this is the thing that we have discussed earlier, that they would be split up into ions. So because of free moving ions, this these acids would be able to conduct electricity. Okay, these acids would be able to conduct electricity. So these are the physical properties. So let's move towards the chemical properties. Okay. So let's discuss about chemical properties. Those are, the first property we have is when metal reacts with acid, they would form a salt and hydrogen gas is produced. Okay. So like for example, there's a metal which is magnesium. When it reacts with acid like HCl, so we know when magnesium reacts with acid, so magnesium would displace this hydrogen. Okay, when magnesium would be displacing this hydrogen, for example, the magnesium belongs from group 2, it would be having +2 charge. Cl is having minus charge, so formula would become MgCl2. Okay, so in this way, the salt would become, that is MgCl2, with the release of hydrogen gas. Okay, so this is gas. Okay, this magnesium basically exists in the form of magnesium ribbon, so that is in solid state. This would be in aqueous form, and in this way, the salt would be formed. As you know, this +2 would move here, minus would move here. So the formula would become MgCl2. So boys, let's see whether it is balanced or not. No, it's not balanced. As you can see that there are two chloride ions over here and there are two hydrogen atoms over there. So two chloride atoms and two hydrogen atoms. In order to balance it, we have to put two here. Okay? Okay. So let's move towards the next important thing. There are certain metals which are not reactive with acids. In order to see that, first of all, let's discuss about uh, there is a reactivity series which state that please stop calling me a careless zebra. Instead, try learning how copper saves gold. Okay. So what does it becomes? Please is potassium, that is K positive. Stop is sodium, Na positive. Calcium, then we have Me magnesium, aluminium, K less carbon, zinc, iron, then we have lead, oh sorry, tin, we have Sn, that is tin. This is lead, that is Pb. Hydrogen is H, copper is Cu, and we have saves, that is silver, and then we have gold. Okay. So first of all, remember one thing, as we are going down the group, so what happens? The reactivity of metals decreases downward. So reactivity of metal decreases. Okay, metal decreases. Now what happens? The most reactive metals, they are present at the top, and the least reactive are present at the bottom. Okay, remember that they are basically two non-metals which are also present in this series, which is carbon and this one is hydrogen. But the reactivity basically decreases downward. These three, copper, silver, and gold. Copper, silver, and gold, they basically don't react with the acids. Okay, they don't react with the acids because they are least reactive. But on the other hand, there is a lead that can react with HCl. Okay, like it reacts with HCl and it forms PbCl2 with the release of little bit hydrogen. But what happens in this reaction? They, for example, this is Pb, this is lead. There is a layer of insoluble metal that would be formed outside the surface of lead. Okay, and that would stop the further reaction. Okay, so there is a layer. Okay, there is a layer of PbCl2. If it is reacting with HCl, so it would be PbCl2 that would form around lead and that would stop the further reaction. PbCl2 formed around lead and would stop the further reaction. Okay, so this is quite simple. Now let's move further towards the next property. Before moving further, I just want to explain you one more important thing, that this when metal reacts with acid, they would form salt and hydrogen. So there is a test for hydrogen that we must need to remember, because that is oftenly asked in the paper as well. So in the case of hydrogen, what happens? There's a lighted splint lighted splint would be put at the mouth of test tube, and that would stop the further reaction. Test tube, and that would stop the further reaction. That would stop the further reaction. Okay, this is very important because that is often asked in the paper. Okay, so now let's move further towards the next property of metals. Acids, sorry. Acids react with carbonates. They react with carbonates to form salt plus water and carbon dioxide. Okay, now let's discuss about the carbonates reaction with acids. So you can see there's a carbonate which is sodium carbonate. This is in solid state and it would be reacting with HCl, and that would form a salt. Sodium reacts with Cl. We know sodium is positive, Na positive, Cl is negative. So the formula would become NaCl. So you can see there is a salt formation that occurs, which is NaCl Along with it, there is production of water and the release of carbon dioxide gas. NaCl is in aqueous form, water is in liquid form, carbon dioxide is in gaseous form. Okay, HCl is also in aqueous form. Uh, there is an important question that people are unable to understand, that what is basically the aqueous form? So aqueous form is when a substance is dissolved in water, because this kind of question was also asked in the exam as well, that what do you mean by aqueous form? So now we can say there is a substance that is dissolved in water, okay, or you can say the solvent is water in the solution. So that kind of solution is basically stated to be as an aqueous form. Okay. So this is about when sodium carbonate or any carbonate reacts with acid, they would be forming salt, water, and carbon dioxide gas. There is a test for uh, carbon dioxide gas as well. Test for carbon dioxide gas. What is that test? That when carbon dioxide gas is passed through lime water, is passed through lime water, lime water, so it turns milky. It turns milky. Okay. Why it becomes milky? Because due to the formation of white precipitates, like this is calcium hydroxide, okay, which is lime water. And when carbon dioxide gas is passed through it, there is a formation of calcium carbonate particles, okay, with the release, with the formation of water as well. So this is calcium carbonate, this is in solid state, this is in liquid form, and this is in gaseous form, okay, and this is in aqueous form. Okay, so there is one more property that I just want to discuss about it. That when acids react with metal oxide, they would form salt and water. Okay. Do you remember that we have discussed about certain metals which are non-reactive metal, that is copper? Copper does not react with acids. This thing we have already discussed. But the oxide of copper can react with. Okay, so what happens when acids reacts with metal oxides? They would be forming salt, copper sulfate. Okay, copper is having +2 charge, sulfate is having -2. So it would be forming copper sulfate. Okay. And with the formation of water as liquid, it is in aqueous form and it is in liquid form. In the same way, acids also react with metal hydroxide, okay, metal hydroxide, and they would be forming salt in aqueous form, okay, and water as well. So acids like, for example, we have nitric acid. It would react with zinc hydroxide. Okay. Zinc hydroxide is in solid state and it would be forming zinc nitrate, ZnNO3 whole twice, and water is formed. Okay. So in order to balance it, we are going to put 2 here. So zinc nitrate, as it was like 2, it was multiplied with 2. So because of that, we have multiplied with 2. And now there are two hydrogen, but here there are four hydrogen. Two hydrogen here, two hydrogen here. So we have to put two over here as well. Okay. So this is in aqueous form, and this is in liquid form, and this is also in aqueous form. Now, there's one important thing, that is role of acidity in water. Remember one thing, acid can only work when it is dissolved in water. For example, if there are two tubes and there is magnesium, okay, this is magnesium ribbon, and we have put this in HCl, which is dissolved in water, and here there is same HCl, but here HCl is dissolved in organic solvent. Okay, dissolved in organic solvent. But we can see one more important thing, that here is present is magnesium as well, but no reaction would take place here. No reaction. But okay. So we were discussing about the role of acidity in water. So what happens when HCl dissolved in water? Only in that condition it would be able to produce hydrogen gas. The reason is that in when HCl is dissolved in water, only in that condition HCl would be able to release hydrogen ion. Okay. So, like in this condition, when it is dissolved in organic solvent, so it would not be able to split up into ions. So, no split would occur over here. So, that is why it is important for an acid to be dissolved in water. Okay, so let's move further towards the difference between weak acid and strong acid, because this is very important question and oftenly asked in the exam as well. Strong acid. Okay. Now, what do you mean by a weak acid? Weak acid is the one. First of all, we know that acids have the ability to split up into ions. But what is the weak acid? Weak acid is the one. Weak acid is the one which partially which partially dissociates into ions. Dissociate into ions. Okay. Partially dissociates into ions. Okay. So first of all, let's discuss about an example of weak acid, which is ethanoic acid, which is CH3COOH. It partially dissociates into ions. So that is why we are using this reversible reaction arrow. It would become acetate ion, okay, and with the release of hydrogen ion. But the reason here is that when it is dissolved in water, like for example, if it is dissolved in water, so यहाँ पे हमारे पास कौन-कौन से ions होंगे? There will be CH3COH ion, CH3COO minus sign, and H positive ion as well. So in water, we can say that this ethanoic acid molecule, there would be the acetate ion and would be the hydrogen ion, because it is not completely split up into its ions. Okay. So what is the definition of strong acid? Strong acid is the one Strong acid is the one which completely dissociates into ions. Completely dissociate into ions. Okay. Like for example, if we have HCl, then you can see when we are trying to split it, when we are trying to put in water, it would be completely split up into its ions. Okay, like for example, here is HCl. When it is dissolved in water, so there would be H positive ion and chloride ion. There would be no HCl, like no HCl would be present here because it is already split up into its ions. Okay. Now, this is the difference between the weak acid and the strong acid. Now, moving further towards, you can say the difference between a dilute acid and concentrated acid. Okay, so dilute acid is the acid that contains more amount of water. Okay, so dilute acid contains more amount of water and less amount of acid. Okay, of acid, it contains more amount of acid. Okay, and less amount of water. So this is the difference that exists between dilute acid and concentrated acid. And in the last, we are going to discuss about the uses of acids that we must need to remember. The first one is sulfuric acid. Okay, and its uses are that it is used to make fertilizer. Okay, and it is used in car batteries. Okay, we oftenly use them in car batteries. And the third one is detergents. Okay, that we use them in detergents as well. Then moving further about ethanoic acid. Ethanoic acid. Okay, we use them in vinegar and we use them in uh, it like to preserve food or in making adhesives. Okay, adhesives such as glue. Okay, then we'll discuss about HCl, hydrochloric acid. It is used in cleaning of metals. Okay, and then it is used in leather processing as well. Then let's discuss about nitric acid. It is used in making fertilizer and also in explosives. Okay, so this is all about uh, our acids. Okay, and now we are going to discuss about bases in our next lecture.